minus y plus xy cube into 1 plus ln x, okay, dx equal to 0. Now we want to rearrange this to look like a Bernoulli's equation, so I can start by dividing through by x. And if we do that, your x dy now becomes dy dx, and your y now divided by x, you have y over x. Divide the whole of this is multiplying, so divide the whole of this by x, you have your y cube into 1 plus ln x, which is what we are supposed to have. Now when we open the bracket, the minus sign now affects, or to have minus y over x minus y cube into 1 plus ln x. Okay, at that point we can take this to the other side of the equation. That's why we have this to be equal to y cube. The minus sign becomes positive, y cube ln 1 plus ln x. Now that is what we have. Now at this point we can choose to divide through by y3, to look like a Bernoulli's equation. So when we divide this by y cube, we get this. Divide this by y cube. Y over y cube actually is y to power minus 2 using the laws of indices. Okay, and that is why we have this. Then divide this by y cube. It eliminates y cube. We are just left with this, which is a first order linear equation. Which is a Bernoulli's equation, which looks like y raised to power minus n dy dx, okay, then minus y raised to power minus n plus 1p equal to q. So you can see that your q is this, okay, and your p is minus 1 over x, then 1 attached to. So to solve this, we can start by saying let v be equal to y raised to power minus 2. So that means your dv now becomes minus 2y raised to power minus 3. You see that? We can divide both sides by dx. So that means your dy here. That means your y to power minus 3 dy dx is equal to minus 1 over 2 dv dx. Okay, so in place of y to power minus 3 dy dx, we have minus 1 over 2 dv dx. Now if we continue from there, you can see now to substitute, this guy now becomes minus 1 over 2 dv dx, okay, then while this now becomes minus v, okay, your y to power minus 2 is v, minus v over x, now equal to 1 plus ln x. So at this point in time, to allow this to be dv dx, to make it look like a first order linear equation, we can multiply through by minus 2, and if we do that, you are going to get dv dx, then here becomes plus 2v over x equal to 2 into 1 plus ln x. You see that? Okay, so that's exactly what we did. Okay, this should be minus 2. You're multiplying through by a negative 2. So we got this particular value, which is a first order linear equation, which we get by first of all finding the integrating factor, which is exponential px. Remember that p is a function of x that is attached to v. So, and that function of x is 2 over x. So exponential integral of 2 over x gives us exponential 2 ln x. Integral of 2 over x is 2 ln x, and exponential 2 ln x is the same thing as saying exponential ln x raised to power 2. Remember the law of logarithm, so this cancels out and we are left with x squared. Okay, so going back to the solution of a first order linear equation, our integrating factor rho is x squared, then you have your v, then your integrating factor x squared multiplied by your q, which is minus 2 into 1 plus ln x. Now if we open this bracket, we are going to get minus 2x squared, okay, then plus x squared ln x. Okay, or we can say, let's clean this up. Let's put that again. You have your integrating factor, which is x squared, then multiplied by this, which is minus 2 1 plus ln x. Okay, so your x squared times minus 2 gives us minus 2x squared into 1 plus ln x, which is exactly what we got here. And we need to integrate this, and the only way we can integrate that is using integration by parts, where we can start by saying our u here would be 1 plus ln x, because we can integrate ln x, differentiate ln x, but not integrate it. Then our dv is minus 2x squared, okay? So from u, we can find du. Differentiate ln x is 1 over x, differentiate 1 is 0. Then from dv, we can find v, which is to integrate minus 2s squared, and that will give us minus 2s cubed all over 3. Okay, so if we are substituting value, uv now would be minus 2s cubed all over 3 into 1 plus ln x. Okay, then minus integral of v du, your v du. Your v du means you multiply 1 over x by minus 2s cubed all over 3. And that will give us minus 2x squared all over 3. Okay, which is exactly what we have here. Exactly what we have here. Okay, and you can see here that this is giving us this. This is leading to this. Okay, minus 2s squared over 3, because your x here cancels this to give us 2, and this remains the same here. There's supposed to be a negative sign here, a negative sign here. Okay, so and that leads us to what we have here, because when we say minus minus, gives us plus. You are going to have plus integral, that's integral of 2s cubed over 3. Sorry for that mistake there. And when we integrate 2s cubed over 3, we are going to get 2 over 3 times integrate x squared is going to give us x3 over 3. So that will give us 2x cubed all over 9. So we correct that. That now leads us to the final answer here. When we substitute your v to be y raised to power minus 2, then here is minus 2x cubed over 3, 1 plus ln x. Then here, like we just corrected now, is 2s cubed all over 9. So that means we can write the answer as s squared y minus 2 equal to minus 2s cubed over 3 into 1 plus ln x, then plus 2s cubed all over 9, then